Next topic, logarithmic decrement. It is defined as a natural log of the ratio of any two successive amplitudes on same side of the mean position in an underdamped system. It is denoted by delta. The delta, the ratio of any two successive amplitudes in underdamped system, is always constant, as you can see from the figure. So once again, logarithmic decrement is defined as the natural log of the ratio of any two successive amplitudes on the same side of the mean position over in an underdamped system. It is denoted by the delta. The ratio of any two successive amplitudes in underdamped system is always constant. So in the figure, as we can see, the figure x1, x2, x3 are in a decreasing order, and y-axis is the displacement, x-axis is the time taken. So time cycle for one is Tp, time period for one cycle is Tp, shown in the figure. So equation for underdamped system, x equals to capital X e raised to minus zeta omega and t sine cos omega dt plus psi, where x e raised to minus omega and t is amplitude and omega d is the damped circular frequency. If sine omega dt plus psi is 1, then the amplitude is maximum. Now the maximum amplitude x is x e raised to zeta omega and t. Let x1 be amplitude at time t1, as you can see from the figure. x2 be the time taken at t2, as you can see from the figure. So now they can be written as x1 equals to x e raised to minus zeta omega n t1, and x2 can be written as, so that is the second amplitude, as capital X e raised to minus zeta omega n at time t2. So these are time x1 x2 are the amplitudes, equation of amplitudes of first and second amplitudes. Similarly, taking the ratios of the first and second amplitudes, we have x1 by x2 is equals to x e raised to minus zeta omega n t1 over x e raised to minus zeta omega n t2. So cancelling out the common terms, x common amplitude, we have e raised to minus zeta omega n t1 minus or minus zeta omega n t2, or can be rewritten as x1 by x2 equals to e raised to minus zeta omega n bracket t2 minus t1, where t2 minus t1 is a time period between two amplitudes. So t2, as we can see from the figure, t2 and t1 are the time period. So t2 minus t1 is tp, time period, that is 2 pi by omega d, or omega d can be also written as 2 pi upon omega n minus or root of 1 minus zeta square. So once again, the ratio of successive amplitudes can be also written as x1 by x2 e raised to minus zeta e raised to zeta omega n 2 upon omega n root of 1 minus zeta square. So omega and omega get cancels. We have 2 pi root zeta minus root of 1 minus zeta square e raised to. So similarly, it can be proved that x2 by x3 also is e raised to 2 zeta or by zeta square root of 1 minus zeta square. Same, this can be same. This can be same for x1 by x2, x2 by x3, x3 by x4, or xn plus 1 is same. That is e raised to 2 pi zeta square root of 1 minus zeta square. Now taking log on both sides, we have log of ln of x1 by x2, 2 pi zeta 1 by square root of 1 minus zeta square. So logarithmic decrement delta will be ln of x1 by x2, 2 pi zeta square root of 1 minus zeta square. Also x0 by xn is xo by x1 and 1 into n, or xo by x1 equals to xo by xn is to raised to 1 by n. Logarithmic decrement delta is ln of xo by x1 equals to 1 by n ln of xo by xn.